Greetings. Thank you so much for joining us. I am David DeWitt, Trade Relations Manager for the Oregon Wine Board, and we appreciate everybody joining the webinar. This is our fourth and final one in celebration of Oregon Wine Month. All of these recordings, or excuse me, all of these webinars have been recorded. This one today will be recorded and available on our trade site. So please, if you want to share it or revisit it, just know that it's available for you. Over the last couple of weeks, we've taken a look at varietals and different styles of wine that Oregon produces. And today we're going to take a deep dive on our climates and soils. Oregon has just such an array of geography and different types of growing regions that it really warrants taking a look at it, because the diversity of regions that we have is very unique. You only find it in a few places in the world. So I am going to turn it over to Bree Stock, our Director of Education and MW. Just so everybody knows, we'll be monitoring the chat and the Q&A. We love trying to answer the questions as best as we can and appreciate everybody's thoughts. So if you have something you want to get off your mind, please just populate that and we'll do the best we can. Bree, thank you again for taking us through these wonderful webinars. I will hand it over to you.
Thanks, David. Welcome everyone to the final in our series for Oregon Wine Month. We are going to focus today on thinking about the soils and the climate of Oregon wine and how they contribute to the quality of wine and the styles of wine that are grown here. So it is going to be a deep dive into the dirt. So I hope you're ready to get your hands dirty and think about, really everything that comes together to make Oregon really one of the most ideal places in the world for high quality grape growing. And it really does come down to this confluence of soils, very diverse soils, mostly younger soils, very enthusiastic grape growers who love to spend a lot of time in their vineyards, and so are really monitoring the quality of the fruit that they're growing and trying to understand how they can make that direct relationship between the soil and what the soil grows and how the vine responds to the inputs of the soil, the nutrients, the free draining capacity, really everything that makes for quality winemaking that comes from the soil. You will often hear, a lot of grape growers saying that soil is very important, but it's about what you do in the cellar as well. The winemakers certainly feel that way. You can certainly taste certain influences of the soil in the wines in terms of how they express certain fruit flavors and certain fruit profiles, and also the viability of the healthy yeast and nitrogen nutrient levels in those grapes when they come into the winery is really because of the great work that's been done by our wine growers in the vineyard. So understanding that relationship between the growers and the winemakers is an important relationship. The other factor that we can't forget about is really the relationship between the climate and our soils and the grapes grown. So how much rainfall we receive during the winter months, how much rainfall or lack of we receive during the summer months, and how that impacts what we're able to do in the vineyard as well, or our need to do less in the vineyard, which is really what leads to a lot of our sustainability efforts, is having a really lovely long dry growing season with limited disease pressure. Makes for great quality grapes, which leads to great wine. So all of those things really are an important factor for the positioning of Oregon wine and how much attention Oregon wine has received, considering that the region, is, really only been planted since the 1960s or mid 60s. So quite, a very good global reputation for a new region has come together because of the growers and winemakers' commitments to understanding this really tight-knit relationship between the soils, what we can contribute to the soils that can really help the grapes thrive and make into quality wine, and really harnessing the potential of our climate and growing season. So with that, let's get into the discussion of how our region began. One of the things that is most striking about Oregon, and Washington for that matter to some extent, and especially the AVAs that we share, is the ability to really observe the actual geological formations while you're traveling wine country. It's completely possible for you to plan your entire wine tour around following the path of the Missoula floods. And then by following that path, you're also led into the eruptions of the Cascade ranges and the confluence of the two tectonic plates coming together, which is brutally visible in the Columbia Gorge region. And as you move further south through Oregon, you continue to see these remnants and examples of this collision of the Juan de Fuca and North American tectonic plates colliding together. And as they brush together against each other over thousands of years, they're actually outlaying different pieces of ocean floor onto the other plate. And so this accreted terrain, as it's called, as these plates continue to come together, is a confluence of layering of this ocean sediment and ancient marine soils being layered on top of each other until Oregon and Washington have really, accreted enough terrain that it rises them out of the Pacific Ocean. So on this map here, you can see that, 200 million years ago is when these plates were colliding for hundreds of years. These collisions were what was layering this marine sediment soil, which really makes up the entire bedrock of the Pacific Northwest. And the Pacific Ocean 200 million years ago spread into Montana and Idaho. So Idaho was out of the water, but most of Washington and all of Oregon was still very much under the Pacific Ocean. So it was these tectonic plate collisions that are still occurring today and still happen regularly. We are on a fault line here in the Pacific Northwest. So these collisions are really what started that transition and that evolution of Oregon and Washington and our distinctive soils. So these marine sediment soils are present most prominently in southern Oregon and also in the Willamette Valley. However, in the Willamette Valley and the Columbia Gorge and Walla Walla AVAs, they're layered with other basalt and low soils from other geological shifts. So 16 to 10 million years ago, these plates continued to subduct under the North American plate, which then is bringing, rising up the sediments of the coast range above the water. All of the Cascade mountain range are formed inland above the water from the accumulation of undersea volcanics. And these continued crashing of the plates are the continued evolution of these volcanic soils. So these volcanic soils are what is then rushing into southern Oregon and parts of the Willamette River and Columbia River as well, until we're having a lot of the soils really obtruding at higher elevations, and so starting to cover these marine sediment soils with the volcanics that are created. So this 16 million years ago, those fissures that are created by the plates colliding, and these fissures in the Earth's crust are really what is creating these Blue Mountains and the Cascade ranges, and really what is separating the difference in growing season and growing terrain between Washington and Oregon. So the Blue Mountains are the mountain range along with the Panousas that are in the eastern part of Oregon and eastern Washington. These very heavy volcanic flows are pouring forth for hundreds of millions of years. So these are pouring over the entire Columbia Basin. And this is actually what has made grape growing conceivable and agriculture conceivable in the eastern part of Washington and along the Columbia River and northern part of the Willamette Valley. These basaltic flows have actually weighed down the landscape enough to take it from being hundreds of thousands of feet high and too high elevation for quality grape growing, to layering it and weighting down the land under this epic amounts of lava flows in eastern Washington, which is really what all of the Washington major AVAs east of the Cascades are formed around, is these immense deep basalt lava soils. These lava flows flowed out to the Columbia, through the Columbia River and out to the Pacific Ocean, but it's really these heavy soils that have made this area viable in terms of not being above 700,000 feet in elevation, where it's just impossible to grow Vitis vinifera vines. So keep that in mind when you're thinking about the differences between Washington grape growing and Oregon grape growing. There's all the grape growing east of the Cascades in Washington is because of this heaviness and layering density of the basaltic flows, whereas the basalt flows didn't flow into Oregon very far. They remained above, Redmond and Bend and the higher desert areas of Oregon. So that's why up in those areas, in Bend and those upper Cascades, we do have some grape growing, but it's primarily hybrid varieties that can withstand some of these high elevations and cool temperatures. So that's the main difference in soil type and in elevation levels. It's also the reason why the majority of Oregon's grape growing is happening closer to the coast, because that Cascade Range is the dividing line in Oregon as to where you can really, be at a good elevation for premium Vitis vinifera production. So then our very much younger soils start to form with the Ice Age. So 2.5 million years ago, the ice shelf is formed, spreading across the Pacific Northwest and Canada, and really starts to, slough and scour away some of these basalt volcanic soils. And as this melt happens, this constant thawing and melting and blowing of ice, what it's really blowing away is a lot of this volcanic lava flow that's been weighting down all of the, the scablands and eastern Washington and northern Oregon soils. This is the part where you can literally follow from, Idaho and Montana, the path of the Missoula floods, and see them very visibly in the vineyards along the, from Walla Walla to the Columbia Gorge and down into the Willamette Valley is where you can see this impact of the Cordilleran ice sheet starting to thaw, and this massive ice dam, which was holding back, thousands of feet of water. And that was in Lake Missoula in Montana. You had this incredibly dense ice structure that was really sort of like, an ice cube sitting in a drink where, it starts to melt and it lessens and the water escapes through it, and then it freezes again, and then more water escapes through it. And so when you're having so much water escaping at 60 to 70 miles an hour traveling through eastern Washington, scouring away all of that very dense basalt lava flows, creating the scablands of eastern Washington, and you can really drive, from Spokane all the way down to the Columbia River and see where these this water effect has carved out almost a bathtub ring of more deeper land that you can now actually maintain, work on, and you can farm, because it's washed away the higher elevations, continued scouring down a lot of that basalt, and it's flowing down into the Columbia River Valley, widening the Columbia River. It deepens and widens that Columbia Gorge, and this is where you're driving along the highway there, and you can see those bathtub rings where the water went to and settled and sat, and where the flood deposits started to settle in the different levels of the Columbia Gorge. Now, remember, this did that about 16 or 17 times over, the hundreds of year period. So this was not something that happened, particularly quickly, and I guess geological forms. But it's very evident when you're traveling through this area. And this is all important for what you're able to grow, and also the nutrients that are able to be retained in these soils. And then, of course, you get the climate coming in on top of that. So we're going to get a little bit more into what grows where and why, and some of the characteristics once we get through this geological part. So the water floods down into the Willamette Valley and parts of the Columbia Valley, and it actually forms Lake Allison in the Willamette Valley, which is the lowest lying part of the Willamette Valley, and is basically, a lot of the area that the Willamette Valley AVA is sourced around. It's also one of the reasons that most of the nested AVAs within the Willamette Valley started around 200 to 250 feet elevation, is because that was where that shallow lake was sitting. And so the soils are very different between that shallow lake and the hillsides. So we'll get into that when we get into Willamette Valley, but keep that in mind about how water moves, what it's bringing with it, the weight of the items in the soil and, in the water flows. So heavier items, a lot of, granites and erratics from the Cordilleran ice sheet and from the Canadian Rockies are taken down and deposited along the river valleys. So you have these granitic erratics, we call them, that are really found in many, or sitting alongside many vineyards in the Columbia Gorge and even parts of the Willamette Valley, as these massive, powerful floods really surge through the Pacific Northwest. So the silty of finer sediments continue to carry further down, and that's what we're left with in the valley floors of the Willamette Valley. Here's another image of the Missoula flood path. So like I mentioned, you can actually drive this, and it's a fascinating drive, you know, and also a lot of fun because you can stop at vineyards and wineries along the way and really understand what is in your glass because of what you're looking at around you. So the channeled scablands in northern eastern Washington carved out because of these flood zones and are carving away a lot of the basalt that was laid down here. The Tri-Cities becomes a large glacial lake, and so does into the Yakima Valley. And then the Wallula Gap, which you pass through on your way from Oregon into Washington and to Walla Walla, is that thin point where everything again gets carved through this massive you know, fold, or the fold banks. If you look at Washington, Washington's, you know, AVAs are in east to west folds because of the tectonic plates. So they're in east to west folds, and that Wallula Gap is one of those folds. And so this channeling of the land, of the water to push through that Wallula Gap and then form another lake before being again pushed further down the Columbia River into Portland and into that glacial Lake Allison in the Willamette Valley. So really relying on the lowest parts of these valleys to rest in. So really beautiful country if you're able to, you know, take a trip and carve it along the path of the Missoula floods. It's still very, very evident here and really important in our conversation around grape growing. So we are going to touch on, I'm going to try and get this done in less than an hour, but it might be tough. So we have around, you know, across the state, most of the AVAs are being in the northern Willamette Valley, where that Lake Allison drained out of. However, most of those AVAs in the northeast that you can see there, sorry, the northwest that you can see there, are above where that Lake Allison bathtub ring would have settled. So very different soil types. So keep that in mind. Keep in mind that Oregon shares several AVAs with Washington and Idaho, Snake River Valley with Idaho, which does see some of that volcanic basalt that carved out with all of those volcanic eruptions, carved out those river valleys in Idaho and the Snake River Valley. And then Walla Walla, Columbia Valley AVA, and Columbia Gorge we share with Washington. So let's start in the northeast, and we'll move south from there. So the Walla Walla Valley, one of the first areas settled and where grapes were first grown in the Pacific Northwest, where fur trappers, you know, 200 years ago settled and brought vines with them from the eastern shores. So Walla Walla is only mildly impacted by the Missoula floods. The Blue Mountains are really still part of that very rich volcanic substract. That means that they're high elevation. What we're starting to see in those Blue Mountains on the eastern edge of Walla Walla is, and to the east of Milton Freewater, are producers and growers starting to settle into vineyards in those higher eastern edges on the volcanic soils of the Blue Mountains. This gives us a climatic factor that, you know, allows for a diversity of growing season and climatic differentiators compared to the western part of the Walla Walla Valley. So Walla Walla is primarily Bordeaux and Rhone varieties. There is Chardonnay and Sauvignon Blanc planted, but primarily it's a region for Cabernet Merlot, Cabernet Franc, and Grenache Syrah. So we're starting to see some producers moving up into the higher elevations of those Blue Mountains, especially for trying to extract cooler climate flavors from some of their Rhone varieties. So more pepperiness and more red fruit flavors in their Grenache and Syrahs. The wind that comes up the Columbia River Gorge actually comes up and blows directly into the Blue Mountains. So a very strong, powerful wind pushes into the Blue Mountains and actually rebounds and comes back at the Walla Walla Valley. But also what you're getting with the elevation of the Blue Mountains is a cooling influence in the evenings that allows cold air drainage down into the Walla Walla River. That carved out region is where this cold air is funneled through. And this also helps to mitigate some of the frost issues and occurrences that can occur early and late in the season as well. Within Walla Walla, so Walla Walla to the west is much more flatter areas and rolling hillsides of more Missoula flood sediments. So volcanic in the east, Missoula flood sediments in the west, and then Milton Free Water is a very unique and distinctive AVA, and probably one of the few AVAs that is it is the only AVA that's delineated by a single series of soils. So it's named after the Milton Free Water series of cobbles and rocks. So again, the Missoula floods rush in, they're leaving behind a lot of silt, but they're also scouring away with them as they drain out some of these heavier silts and leaving behind a lot of these cobbles and volcanic cobbles, which have settled in the deepest part of the riverbed, which is what Milton Free Water is. So this alluvial fan of an ancient river, the Walla Walla River, that has been drained out of its really fine, low sediments and has a lot of heavy cobbles in the first several meters of its soil. So this is where some of the most distinctive Syrahs are being grown at the moment. If you've ever had a Syrah from Milton Free Water, you will recognize it as being distinctly different to any Syrah that's grown around it, because it has a propensity for a more deeper umami flavor, more meaty, savory, black olive, almost like miso soup characters in the savoriness of these wines. And some of the most distinctive Syrah that's being grown and distinctive savory wine styles that are being grown in the US, which is, why AVAs are really carved apart, is for their distinctiveness. And the Rocks District of Milton Free Water really has that in spades, especially combined with its high heat degree days during the growing season, a relatively short growing season because they are impacted by frost. But you can see here that they really do spend a lot of time in that upper 80s, 90s echelon. And keep in mind, this is, day and night temperatures during the growing season. So you can see a relatively good variation between nighttime and daytime temperatures, but those temperatures are very hot, very cold in the winter, very hot summers, very low rainfall during the growing season, which again helps to contribute to more sustainable practices in this area as well. Irrigation is required for the vineyards here, but most of these vineyards are being farmed relatively low or trellised relatively low to the cobbles and the rocks, so that the grapes can benefit from the extended heat release during the evening to keep the temperature a little warmer during the evenings and continue that immense or intense ripening during that short hot growing season. This also adds to really refined tannins in the wine. You taste a Syrah from this area, and the tannins and the fruit and the density of the fruit are very silky and fit very well together, hand in glove, because of that sort of extracted ripening during the growing season and the moderation of the tannin profiles there. It's hard to get a lot of hard green tannins in the fruit from the Syrah and Grenache in this area. It's very silky. It's very fine-grained tannin profile that really sits with the weight of the fruit and the umami flavor profile of the fruit as well. So these are the three main soil types in Walla Walla. So as I mentioned, the loess, which sits on top of that Columbia River basalt, the basalt cobbles, a lot of which were brought with them by the Missoula floods and settled in that lowest part of the valley as well. And then the Missoula flood slackwater sediments. So where the slackwater sediments, where the water comes in, rests for several years and drains slowly out. So that layering that you see are those 50-year floods over and over and over again. It's like being at a beach and looking at the tide coming, the waves coming in and out. So very beautiful place to visit and to think about what you're drinking and how that translates into your glass as well. So the Missoula flood strip away the fertile soil, leaving behind cobbles and boulders in those, vast areas of the banks of the Columbia. And then they narrow through the Wallula Gap, where you can't really get that much water through. So that's where those slackwater sediments come from, is that bathtub that became when you can't push all of that water through the Wallula Gap. So really unique soils. What they do is allow the grapevines to dig deep to try to penetrate for additional water and nutrients into the basalt below. So very fine-grained sediments that allow the deep roots for the grapevines to go very deep. And you can see the cobbles here and the low soils and just how intense they are, how minerally and dark the soil is here. This soil also is very high in nutrients and in nitrogen. So these wines really do not have any trouble fermenting on their natural yeasts. They have very high YANs and yeast assimilable nitrogen levels because of the intensity of those soils and the nutrients that are left in those soils. The gravel deposits in the alluvial fans are also coming from that Blue Mountains as the rivers and the rains wash down into Milton Free Water. It transports further basalts down into the Walla Walla Valley. And so that's how you're left with those deposits of the rocks in Milton Free Water. Again, that combination of the Walla Walla River moving over millennia and leaving behind those deposits as well. So a layering effect of the Missoula floods and then the Walla Walla River movements from rainfalls up the Blue Mountains. So the basalt cobblestone gravels formed from the Columbia River basalt rocks, which eroded from the Blue Mountains and left them in that alluvial fan. Keep in mind that rivers move all the time over millennia. So that is where the Milton Free Water AVA is now. But in the past, that was the Walla Walla River as well. So those cobbles settled, they are 200 to 300 feet deep, so nearly 100 meters deep. And so can you imagine trying to plant a vineyard here? It's a lot of work. And then all of those cobbles are really encouraged to remain at the top so that they can continue to ripen the fruit during the short growing season there. In addition, you have the Ice Age floods, deposits, silt and sand from the Columbia River Valley, and the winds, the very strong winds that blow up the Columbia River along the Columbia Gorge are really what is dusting the hillsides of Walla Walla. So 3 main soils in Walla Walla, those volcanic basalts on the eastern edge of the Blue Mountains, the Rocks District cobbles and loess, and then the windblown loess that's deposited on the northern and western hills of the Walla Walla Valley. So free draining soils. Those loess soils are quite nutrient poor, but many people are really trying to persevere with cover crops. However, given a dry season and nutrient poor soils, they just don't stand a lot of chance in those vineyard areas. So really, you don't need to do a lot here to amend the soils, but fairly poor soils, and they're very fine grained. And again, these low soils are one of the reasons why the majority of Washington and Walla Walla is still on its own roots. So one of the few areas in the world where grapevines or Vitis vinifera can still be on its own roots, because the phylloxera louse doesn't really like low soils, and also it's quite low nutrients. And so that feeling of the soils is really helping to prevent the spread of phylloxera in those areas, and one of the few areas where you still get own-rooted soils. So these low soils you see all over Washington and a lot through the Columbia Gorge AVA, and then just down into the Willamette Valley, into the Laurelwood AVA and the Tualatin Hills AVA. So they're weathered, windblown soils of that really granitic bedrock and basalt bedrock that was blanketing the Columbia Valley. And very, very free draining. You really need to irrigate the vines in those soils in a hot climate. So as an overview, Walla Walla is far from the marine influence of the Pacific Ocean, but it still benefits from the winds coming up that Columbia Gorge, has a very large diurnal range in temperatures between daytime and nighttime temperature, helping to preserve the acidity in the grapes at night. And then you have a lot of different microclimates in the foothills of the Blue Mountains, where it's really ideally suited to the cooler climates of Rhone and some Iberian varieties. And then the more open and free draining headlands for the Bordeaux varieties in the western part of the Walla Walla AVA. So lots of full-bodied, high alcohol, very complex, age-worthy wines coming from these hillsides and river floor alluvial fans in the Walla Walla Valley. We're going to quickly touch on the Snake River Valley. We don't often talk about it, but it's a unique area for grape growing. You can see here the soils, that volcanic basalt. So it's a dusty volcanic basalt, also covered with low soils as well, but primarily volcanic basalt. As you move down closer to the river, you start to get into carved out sedimentary soils as well. So about 70 miles south of Walla Walla, you start to hit the Snake River Valley. It's a very intense, deeply carved river valley with high sides to it, and the vineyards sit at high elevations. It gives quite aromatic, but also ripe styles of wines. So much more tropical fruit flavors in white wines, and then much more almost not raisined, but very full, very dried fruit and complex big black and purple red fruited styles of wines from that river valley. Again, the wind here is important as it snakes down through that river valley as well, helping to cool the vineyards. And again, it's a huge diurnal temperature shift between day and night as well. There's not a lot of wineries in the area, and especially on the Oregon side, but these are increasing and they're showing really great promise for some really beautiful Iberian and Southern Rhone varieties as well. So it's a place to definitely keep your eye out for, and a beautiful place to visit as well, and not far from Boise. So if we travel west from the Walla Walla Valley now, we'll drive through the Columbia Valley AVA, which we share with Washington, and then we'll hit the Columbia Gorge AVA, which is also shared with Washington. So it's 40 miles long, but it really does change quite dramatically from the westernmost edge to the easternmost edge. So higher desert, much more Walla Walla, Columbia Valley style wines on that eastern edge of the Columbia Gorge, through to the western edge where it's a little more like the Willamette Valley. You're getting the influence of the Pacific Ocean. You're getting Pinot Gris, Chardonnay, and Pinot Noir grape varieties being grown, along with a handful of aromatic Alsatian varieties. And then right in the middle, you're starting to see some really fun Iberian varieties like Mencia and Godello and Tempranillo being planted, and Alvarinho being planted, and really benefiting from that cool river valley with the intense wind that blows down this valley. So you can see it's quite a small AVA here on that western edge of the Columbia Valley. So established in 2004, it's only 120,000 acres in size. Keep in mind the Willamette Valley is 3.5 million acres, and the planted area is just over 2,000 acres. This is a very complex geological soil formation in the Columbia Gorge. You are surrounded by mountains. It has to be one of the most picturesque AVAs to visit and to grow wine in. There's also a very fun orchard loop called the Fruit Loop, where if you are there in the right time during the summer, you will just gorge yourself silly on the most delicious cherries and peaches that you've ever seen. And of course, you have just a huge variety of wines that you can taste and understand. So, you know, really surrounded by mountains. You've got Mount Hood, Mount Adams, Underwood Mountain are really close and really impact how the climate really transitions here around those vineyards. So you still have, and this is one of the places where the Missoula floods and that bathtub ring of the flood sediments is most evident. It's also a place where you can really still see that tectonic plate collision and the sliding of where Washington and Oregon come together, that crumbling of the Columbia River. So really one of the most just dramatic vineyard region sceneries that I've ever seen. And I've been to most around the world. So it's really a place not to miss if you can ever get to Oregon to visit. So volcanic basalt soils, very young volcanic basalt soils, and volcanic lahars. So where the volcanics have spread and the lava has flown down and then eroded is your lahar soils, varying sizes and weights and densities of those basalt soils there. Then, of course, you have the windblown loess sitting on top of as well. And then the remnants of the Missoula floods, those silt and sand soils towards the lower elevations and the reaches that sit right on the Columbia River there. Incredibly beautiful, great deep soils. You are able to do a lot of head trained vines here, so you don't require a lot of trellising. You also need a lot of wind breaks in your vineyard because the winds here, this is one of the places in the world where it's a mecca for you know, windsurfers and kiteboarders because of the strength of the winds that come down this valley. So you really need to pick a sheltered aspect for your vineyard in the Columbia Gorge, AVA. And then as you move from west to east, you start to get the intensity of the rainfall really shifting. So on that very western edge, you're getting roughly 40 to 50 inches of rainfall annually, very similar to what the Willamette Valley receives. And then as you start to move to the east, you start to get into lower rainfall. So 30 to 40 inches moves quickly into the 20 to 30. And then finally at that eastern edge, you're at about 10 to 20 inches and starting to push into, at some of the higher elevations, these high desert soils. So again, more loess, more silt and sand from the Missoula floods, very free draining soils, quite nutrient poor. And so the struggle here is between irrigation and wind management as well. A very sustainable region where there was a lot of organic and biodynamic farmers also. Because of that wind influence, you really don't have a lot of disease pressure. So very fortunate to be in that, nice confluence here of the heat and the wind, and really being able to add irrigation on that eastern side when and where it's necessary. So very precision irrigated soils here, as is much of the rest of the Columbia Valley. Yans in the gorge vary. They can be quite low because of the nutrient poorness of the soils. And so some soil amendments need to be made to ensure that you're going to get some decent yans. But once you can establish a cover crop that you can, put back into the soil, really to try to build some of those nitrogen levels, you can really start to build those yans. Sorry, what is YAN? YAN stands for yeast assimilable nitrogen. And nitrogen in the grape must is what yeasts are able to ferment into, the sugars in the grapes into alcohol. So nitrogen in the grapes is really food for the yeast. So when we're thinking about it from a winemaking perspective, YANs are quite important for us. Yes, we will definitely record and share this link with everyone as well. Thanks, Pam. So yans are very important for winemakers, and it's one of the questions that most winemakers will talk around. It's one of the decisions as to whether you're going to need to supplement your native yeasts or indigenous yeast populations in the must with other nutrients or other phosphates to really build their population and make sure that they have enough food to get through the fermentation and to ferment the wines to dryness. Temperature and precipitation in the Columbia Gorge, as I mentioned earlier, it's very dramatic depending on what part of the Columbia Gorge that you're in. If you're closest to the western edge, you're going to get a lot more rainfall, up around that 40 to 50 inches, just like the Willamette Valley, and slowly moving to further dryness as you move east. Weather is really moderated by the wind here, so you get quite cooling influences from the winds, but also keep in mind that you have so many mountains surrounding you that those mountains create their own cloud formations. And so you tend to get some more covered skies, depending on what, cloud formations and wind conditions, cool or dry wind conditions, those mountains are creating as well. And you get a very natural push and pull between the Pacific Ocean, which is very cold and cool, and the eastern part of the Columbia River Valley. And so we know that, just like in California, when that eastern hot high desert country starts to heat up and dries out, what it does is start to suck the humidity and pull that cool coastal weather from outer Astoria and the Pacific Ocean area, and that pushes back with a vengeance right up the Columbia River Valley, and you get this incredibly intense dance between the hot weather, high desert weather, and the cool Pacific Ocean maritime weather occurring there. And that's really what makes a lot of these wines so vibrant and so energetic and have so much good acidity still, is that confluence between that dance of the cool ocean and the hot high desert. And it is also why a lot of, the area in that Columbia River area is we don't really need to irrigate a lot. We also don't have a lot of intensely hot days. You get 3 or 4 hot days, and then that Pacific Ocean comes in and cools it down. So it's a much more moderate climate than what you're getting further east in the continental areas. Great, thanks, David. Okay, moving on. So this is showing the wind, what I was just talking about, that wind that pushes down from the Pacific Ocean, cold, sustained winds. But it really only comes when this area in here has heated up so much that it's sucking and causing a vacuum, pulling in that wind. And then during the winter months as well, this is when we get most of our rainfall, primarily on, again, that western edge of the Columbia Gorge AVA, where the wind comes through, whipping through that Columbia River Valley there. And then also keep in mind that this is the Cascade Ranges, so we do have higher elevations. It's just that the channel here of the river has made a lot of benchlands and viable vineyard areas to plant at some of those lower elevations. And then those ranges as well also help to block some of that wind and rain that comes from the west into the Columbia Gorge AVA. Just a beautiful place to visit, immensely beautiful, and some fantastic and really diverse wine varieties and styles being made there as well. So the 4 soil types. Good question, Erica. What is the effect of the recent longer summer heat waves on the Willamette Valley? We'll get to that in just a minute as soon as I get into the Willamette, which I promise is just in a second. So Columbia Gorge, volcanic soils, Columbia River basalts, the Cascade mountain stream sediments, and then the Underwood mountain basalts, which also contribute to the Lahar soils, the slightly lighter alluvial volcanic flows, and then Los, and then those Missoula fast slack water deposits. The basalt, Columbia River, decaying basalt that was spewed out into the valley from the Cascades, fewer nutrients than marine sedimentary soils. A lot of it scoured away in the Missoula floods 15 million years ago. The Dells Formation, you can see some of the unique rock formations here. This is literally the highway that you drive along. So you can see a lot of these eroded Cascade Mountain volcanics formations and stream sediments. So Underwood Mountain, the eruption, is what you can still see hovering on the northern shore of the Columbia Gorge. It's a very intense volcanic area, and it's drastically different to the southern part or the Oregon side of the Columbia Gorge. But there's still a lot of weather and climate that mountain there really inputs, it creates its own weather systems. And this is where a lot of the higher elevation vineyards are really being planted now. And a lot of Oregon producers are sourcing from the Underwood Mountain side and some of the soils over here as well. So that's the Underwood Mountain basalt. So low soil nutrients, but good draining, and helps to moderate the vigor in the vine. And then these are the lahar formations that come from those eruptions of the volcanoes in the Cascade ranges. And it's definitely very old soil, has low nutrients, and is pretty thick, and helps to retain soil in the water in the wet part of the season, but then dries out to be quite fine grained and free draining. And then the low soils, which again are blown around down the Columbia River Valley, and then deposited along the Hood River AVA, but also into the northern part of the Willamette Valley. And you can see that represented there on the Chehalem Mountains flank and into the Tualatin Hills AVA. So very fine grained silt, low soils, very well drained, it retains water during the early part of the season, but then goes out to be very fine drained and fairly low in nutrients as well. And then the Missoula flood soils. Slack water deposits. As I say, Columbia Gorge, one of the most intensely, exotic regions that you can visit, and you can really see all the soil types when you're visiting there. It's so beautiful. You can just look at it there. It's a must stop for anyone. So climate transitions from maritime on the west to continental in the east, only about 40 miles in length, and then elevations from about 2,000 feet from sea level up to 2,000 feet. So those benchlands right on the river where it's like silty, sandy Missoula flood soils, up to the higher level volcanics and lahars. And again, those winds that gust up to more than 20 miles per hour really act as a cooling and drying force in the vineyard, but they also help to slow down the ripening in the vineyard there as well, as the stomatas and shut down and delay or prolong the ripening season there. Lots of different grape varieties planted. It's a real region to discover. Okay, moving into the Willamette Valley, where we really just focus on 3 major soil types here, which is kind of nice, especially in a region that, has a lot of the same variety, and you can actually see the differences of how some of these soils influence the growing of Pinot Noir in the different AVAs. And it's nice also that a lot of the AVAs have really been outlined, by their soil type as well, even though there's some mixed soils as well. So as we, so northern Willamette is really where a lot of the AVAs are at. Temperature and precipitation is important. It's damp, cool winters, warm, dry summers, pretty typical of a Mediterranean or maritime climate. Again, we get similar rainfall to, Galician Spain, 50 inches annually. It's pretty wet during the spring and winter, and then in the summer we completely dry out fairly well into the fall as well. So that crucial growing season is really quite warm and dry, and we don't have a lot of cloud cover. So this means that we get a lot more UV intensity coming into the grapes. This helps with the phenolic ripening of the grapes and also helps to increase anthocyanins in our grape varieties here. So Pinot Noir in the Willamette Valley tends to be deeper colored, darker colored, and have more tannins than Pinot Noir grown in a region like, say, Burgundy or the Loire, where it's more continental and they have more cloudy weather and rainfall during the growing season. We are much more similar to Central Otago and those other high elevation, high UV areas, or Galician Spain, very Mediterranean, where we don't get that level of rainfall, we don't get that level of cloud cover during the growing season, and the UV exposure combined with our very warm weather really helps to increase the phenolic and physiological ripeness of our grapes. grapes. So giving us, while we're such a very cool northerly region and one of the coolest growing regions in North America, we do still have a very good opportunity to ensure ripeness every single year. Even in grape varieties like Cabernet Franc or even Grenache in the Willamette Valley, it's capable of ripening many different grape varieties. So really only hampered by this type of grape variety that's grown here as to, you know, the style of the wine. Wind here as well is important. It comes in through two passages in the Willamette Valley. I want to get to your question about going back to the heat waves here. You know, we've had a couple of heat waves in the Willamette Valley that have, you know, intense heat will shut down a grapevine. So what it does is sort of stagger our ripening process and pushes it a little bit further at certain times into September. It depends on when the heat wave hits as to what impact it is having on the vine. For example, in 2021, we had that 160-degree day heat wave in June, but the berries were only just starting to really set and be formed. So what that meant for the vine there was that a lot of vines, especially younger vines, tended to produce smaller berries and smaller clusters, which really led to more concentrated and more structured fruit in the 2021 vintage. So the 2021 wines are some of the best wines that I've seen out of the Willamette Valley. They have so much fruit intensity and so much structure. They're just such giving wines because of the size of the crop. You know, unfortunately, that's not too good for grape growers, but for wine quality, it was really one of the best vintages that we've seen recently. So yeah, a lot of those should just be starting to hit your shelves as well. Really beautiful, beautiful wines. And thankfully, the rest of that 2021 season really wasn't too extreme. We didn't have too many days over 95. And again, because of this proximity of the Pacific Ocean, like the Columbia River Gorge, we tend not to have more than 3 or 4 days of intense heat at a time. We get that push coming in from the east, the hot weather, the high desert, the dry heat that, you know, some days you get here and it can be 100 degrees and you feel this intense, you know, wind blowing in from the east that feels like you've just opened the door to a convection oven. But that really only lasts for 3 days. And then you get the pushback from the Pacific Ocean and it will cool down rapidly, you know, so much so that you need a sweater in the afternoon, almost, you know, reliably from about 5 o'clock onwards on many of the summer days here. We get very, very hot in the afternoon, and then that Pacific Ocean gets channeled into the valley and really cools down the vineyards and us, thankfully, and helps to restore the acid or keep the acid in our grapes as well. Here's a quick outline, very rough outline of the soils. This is a generalization of the soils in the Willamette Valley. So you can see here those low soils that we spoke about, those fine-grained windblown low soils are in the Tualatin Hills AVA, that most easterly and most northerly AVA that catches the wind coming down the Columbia River Gorge. This is also one of the latest AVAs as well. It's quite cool, depending on where you're located. If you're more on the western flank, closer to the coast, you're quite late here. As you move further east, you're getting a little bit warmer and benefiting from those drying, warming winds that are coming down the Columbia River. Laurelwood District, again, low soils on the belly of the dinosaur that's standing on its head. And then you get into volcanics. So this is where the marine sedimentary soils are those ocean uplifts. So the soils here are sort of a concertina of how the soils have been formed over millennia. So you get the ocean uplifts and then the basalt soils that flow down into the northern part of the valley. And then you get some of them that were eroded away or had loess dusted on top of them. So 3 main soil types, Laurelwood, Tualatin Hills, loess, Ribbon Ridge, Yamhill Carlton is primarily sedimentary soils. Vendusa Corridor, primarily sedimentary, ancient marine sediment soils. And then the volcanics, the basalt volcanics, are really in McMinnville, Dundee, and the Eola Amity Hills. And the lower Long Tom AVA as well, and Mount Pisgah of Polk County as well, which is just below the Eola Amity Hills or Vendusa Corridor AVA there, a nice volcanic hill that sits out there as well. Volcanics, active volcanics around the Ring of Fire. So just reminder that most of the West Coast vineyards are primarily volcanics. Again, that marine sedimentary soil, very free draining, but has some good nutrients, but helps to moderate the vigor as well. The volcanic basalts, those volcanic basalt clays really retain the water during the winter and spring months that allow us to be a dry farmed region here, majority. So those intense, water retaining volcanic basalts really meter out the rainfall and the water to the vine as it's needed, and really gives really beautiful spice and red spice and fragrance to the Pinot Noirs coming off of those soils. The marine sedimentary soils tend to be more blue fruited and plums, with sometimes a little dusting of grapefruit or ruby red grapefruit in the profile as well. And then those windblown loess soils, depending on how deep the loess is, remember that this loess is sitting on top of the volcanic basalt. So you get that the water retention beneath, and you get this the vines really going deep into the loess to go for that volcanic basalt to reach the water aquifer and where the water retention has been held. So those windblown loess soils really depend on how deep the loess is in those areas as to what style of wine you're getting. If it's quite deep loess soils, your wines are going to be quite perfumed, quite in that red floral red berry spectrum. But then if they tap into the volcanic basalt, you're going to get a little bit more structure and muscle coming through beneath that profile. So again, those marine sediments are formed from that smashing together of the tectonic plates, which are the important parts of the marine sediment soils in Chehalem, Ribbon Ridge, and Yamhill Carlton. So sandstone and siltstone from the ocean floor. They're quite pale and mustardy in color. They have low pH, so less nitrogen is available in the soil, and then it forces the roots to go deep in search of water and minerals. So pretty good for balancing the vigor of that 50 inches of rainfall that we get in the winter and spring months. The volcanics of the Blue Mountains and the Cascade Range really formed our volcanic basalt soils. And as you can see, they didn't form all the way down into the Willamette Valley AVA. It's very isolated to primarily the north and the eastern part of the AVA. However, where they are, it is varying depth. Jory volcanic basalts tend to be much deeper and more iron rich, and the Nakaya volcanic series tend to be more down in the Eola Amity Hills as you're getting further away from that volcanic basalt flow, and they tend to be thinner. So a thinner layer of volcanic basalt down then into the marine sediment soils. And they're most prominent in the Dundee Hills, McMinnville, and Eola Amity Hills. They give wines that have a little bit more structure, a little bit more spice, and tend to be quite age-worthy styles, but they can border into that sort of tea leaf, bergamot tea, sort of rustic, almost tannin profile in those tannins there as well. But they're very, very perfumed and very intensely floral. So high in clay content and iron, giving it a red hue, and then retains water better than the marine sediment soils. So helps dry grown vineyards during the hot summers that we have here. And then after the Ice Age, we get those, again, those windblown silts forming on the northern part of the AVA in Laurelwood and Tualatin Hills, some of the newest AVAs. And again, depending on the depth of those soils, they're quite vigorous, but they allow a very expressive red fruit profile as well. And also some of the earliest drinking styles as well. The Missoula flood soils that came down, they're primarily on the valley floor here in the Willamette Valley. And so we don't have too many vineyards really planted on the less than 200 feet elevation of the valley floor because of that fertility, because they're just too vigorous and it's too much canopy to maintain. So Scott Henry canopy system was developed here in Oregon, just outside of Eugene and the Umpqua, and that's a split canopy system to try to balance more of that vigor from these very nutrient dense Missoula flood soils. The Missoula flood soils here are primarily grown to filberts or hazelnuts, berries, and also to grass seed. So Willamette Valley overview, one of the coolest wine growing regions, northerly latitude, but with extended hours of sunlight. We get about 2 to 3 hours more than Sonoma or Napa does. So that UV extended warmth really helps us to develop ripe, complex fruit profiles in our Pinot Noir, Pinot Gris, and Chardonnay as well. There's a lot of diversity starting to happen here in the Willamette Valley as we're understanding our soils a little better and our microclimates, and also have more access to more varieties. Okay, Southern Oregon, we're nearly there, I promise. I know you guys are doing great and hanging in there. Sorry, it was kind of a fool's errand to think that I could get through the entire state of Oregon and part of Washington in 60 minutes. So I apologize for running you over, but this will be recorded and available. So join us if you have to go for the Southern Oregon part at your leisure on the recording. So Southern Oregon, really, again, one of the most beautiful AVAs. Southern Oregon, as an AVA, was created in 2004. It does encompass 5 different AVAs, which are really defined around 4 rivers and 3 major mountain ranges. Really varied aspects and soils create a vastly different style of wine and quality here as well. It's really a fun region to visit, and it just really tacks on to the bottom of the Willamette Valley. So to drive from Portland to the northern part of Southern Oregon is roughly 3.5 hours, 5 hours to get you down into Ashland and the heart of the Rogue Valley. So Southern Oregon, you know, it's close to the same size as an AVA as the Willamette Valley, so around 2.5 million acres. Not quite as much, maybe around half of the amount of plantings as the Willamette Valley has, primarily marine sedimentary soils, alluvial gravels, and volcanic soils as well. Again, the primary variety here is Pinot Noir. So Pinot Noir and Pinot Gris are really prominent in both the Umpqua Valley and the Rogue Valley. What I love about visiting these regions is it's such a gentle transition from the cooler Willamette Valley and the very perfumed and lighter bodied styles into that Umpqua Valley, where you still get more of that, you know, cooler, wetter Willamette Valley style profile, especially in the northern part in the Red Hills of Douglas County and Elkton, that are really close to the ocean and benefit from that ocean influence, and also from high elevations. And then as you start moving closer to Roseburg, you start getting into more of these ancient sandstone and marine sedimentary soils that are carved also by the river systems here as well. So elevation is really important, aspect is really important, and there are a lot of fault lines in this area. So every fault line has a different piece of soil that is really obtruding from that piece of land. So there's a lot of producers in the Umpqua Valley that are so dedicated to understanding their soils that they're planting very specific, Malbec on this type of volcanic soil, Syrah on these gravelly soils that are uplifted from a fault line on the western part of the Umpqua Valley, Tempranillo on more sandstone and high elevation free draining soils. So the wine growers and winemakers here really are committed to understanding the soils and really harnessing the best from these soils here. Moving further south into the Rogue Valley, you start to fan out a little bit in terms of where the river systems take you. So to the east, you have the Cascades, which you get a lot of cooling influences off of, but this is a broader area where the sandstone is fanned out, and you really follow the Rogue River Valley down here. And then to the west, you're taken into the Applegate Valley, which again is a region that's really been defined by these river systems that just meander over the millennia all over the place and are really carving out a lot of these different alluvial soil types. So it's very distinctly different. And again, people who have worked in this region for decades are really adept at understanding what varieties are going to give the best performance and also distinctive characters and aromatics on each soil type. So a lot of this area is formed by the ocean uplifts. As you can see, this is if you're looking to the eastern side of the valley into the Cascades, you can see that lower rainfall, very much more open sandstone cliffs, quite nutrient poor, and just rolling hills that build into mountains. So a lot of the vineyards here will be on the valley floors around the rivers, and then just moving into the foothills, so that you're, you don't need a lot of that intense sunlight that you need to plant on a steep slope here. Southern Oregon is much warmer than the Willamette valleys, or the Rogue Valley is much warmer than the Willamette Valley. So planting on the valley floor where the vines are going to be shading each other from the intense sunshine that comes down is really important. So here at Two Hawk, they grow incredibly intense and detailed Rhone and Bordeaux varieties primarily. And this has a lot of alluvial gravels because this is, where the Rogue River used to be and the Bear Creek Valley. So lots of different river systems that have come through here that have deposited all of these alluvial cobbles and silty soils here. Very distinctive vineyard here, but really important to be on that flat land so that you're getting some shading of the vines instead of looking for the higher aspects where you're going to get a lot more sunshine on every single row coming down. So this is where, vineyard management and really defining where the best places on your site are really comes into play. I love wine. You can geek out on it in so many different ways. So temperature and precipitation in Southern Oregon, as I was just mentioning, the summers are warm and dry, very large diurnal temperature swings. In fact, some of the largest in the world, much like Mendoza and South America, Southern Oregon has these drastically different temperature shifts, often down to 45 degrees overnight and back up again to 95 degrees during the day. So very, very intense changes, very warm during the day, getting a lot of that anthocyanin development, getting a lot of fruit ripeness, and slowly accumulating sugars, but then at night dropping back down to cool temperatures, which helps to preserve the acids, and also helps to, wake the vine up again after the intense heat of the daytime. During the winter, a fair amount of rainfall in these areas, and also snow. I think I was chatting to someone the other week, and they just had another snowfall down in Southern Oregon. So, it's nearly June and we're still getting snow in parts of our regions. So it's quite dramatic down here, and also just one of the most beautiful places in the world to visit for wine as well. And the beauty of it is that you can transverse the entire valley from Umpqua, from the north, where you're playing around with Pinot Noir and Chardonnay and Alsatian aromatic varieties, all the way down through into the Iberian varieties around Roseburg, Tempranillo, Grenache, Syrah, and then Alvarinho, and then down into the Rogue Valley, where you're really committed to Rhone varieties and Bordeaux varieties as well, because that drier, more riverbed soils really suited to some of those varieties. Think about Bordeaux and the Rhones in France, and it's a very similar feeling in that area. So the marine sedimentary bedrock is very ancient down here, and then you get those volcanic Cascade mountain sediments and the Silesia terrains. It's those Silesia terrains as well that are really bringing a lot of aromatics to some of the Rhone varieties and Bordeaux varieties here. You get very fragrant Cabernet Franc and Merlot, lots of violets, and then Syrah again has a lot of pepper and fresh aromatics because of those terrains and the stream sediments as well. So sedimentary soils, again, coming from that tectonic plate and accreted terrain, all of the layered on marine sediments coming through there. The sedimentary bedrock here has higher clay content and is a deeper hue. And then the clay composition means that the vines really struggle to go very deep to reach that water table as well, but it really helps the area not have to use irrigation in the early part of the season and allow the vines to struggle and really, build structured wines, and then allowing irrigation just at the very peak height of the season for a few weeks. The volcanic eruptions, similar to the northern, the Cascade Mountains erupt and really start to loose basalt down just into that Bear Creek area on the eastern side. So the lava covers the mountains and gives some pretty rich volcanic soil in that northern part of the Rogue Valley. And then this is where you get a little bit more of the structured clay, the soils that are better suited to Malbec, Cabernet Sauvignon, Cabernet Franc as well. And that eastern part of the Rogue Valley is really where you're seeing these very age-worthy, fine-grained tannin, intensely perfumed and rich, ripe Bordeaux styles coming out of. There's a lot there that just have so much elegance and energy to them, as well as the intensity of the ripeness as well. The volcanic sediments from an underwater plateau. Oh, this is the Red Hills of Douglas County. That's the only part of the Umpqua Valley that has a very intense volcanic basalt soil profile. And it's a single almost a monopole AVA, if you will, with just one big vineyard there that's actually being replanted as we speak. And so there should be some really beautiful and interesting wines coming out of there as well. But it's pretty unique, but hard to find any wines from that AVA. So we won't spend too much time on that. This is the stream terraces and fans. So surrounding the river systems, which are really important in a hot area, the rivers help to move air and bring cool ocean influences. And as you can see, the Umpqua River and the Rogue River and Applegate River, which is a tributary of the Rogue River, they are bringing this east-west Pacific Ocean influence coming into these hotter landscapes as well. Pretty intense valleys here. So you have a very short bedrock or bench land, if you will, of that, where that river has meandered and where the river is now to the bench land that it's left behind. And that's what you find a lot of in the Applegate Valley, is these really lovely Rhone varietal vineyards planted on these former rivers that have a lot of rocks and gravels and give a lot of perfume, higher acidity, and delicate structure to the wines. And then above that, you have the Kubli bench soils, which are more structured, more powerful wines as well, coming from those more ancient riverbeds and volcanics as well. So silt and sand and gravel tend to give wines that have a very silky mid-palate, quite a lot of perfume as well, and can also help to retain a lot of acidity in the wines as well. Some of my favorite Grenaches and Syrahs come off these soils in the Applegate Valley and Rogue Valley, and they're just so elegant and so fragrant. And it's nice to be able to sort of carve out parts of the AVA to really seek out where the Rhone varietals are in the styles that you like, as opposed to moving over to the east, where there's a little more heat and weight that you're going to get into the wines as well, and a little bit more structure. So cooler in the Applegate River part, and a lot more diversity in terms of the soils and the terrains there. And then the sandstone and sedimentary marine soils on the eastern part of the Southern Oregon, the Rogue Valley AVA, where vines can really go deep into the soils, really have higher elevations coming into play, especially with Chardonnay and Pinot Noir, which are still really important varieties in the Rogue Valley and Applegate Valleys, even though we don't hear as much of it as we do from the Willamette, but really beautiful styles of spiced, ripe Pinot Noir styles as well, that can really benefit from the vines going very deep into the sandstone and marine sediment soils, and combined with all of the confluence of those mountain ranges, the Siskiyous and the Klamath Mountains that are bordering the California border and the Cascades there. A lot of cooling weather influences are being created in those high elevation mountains and trickle down into the valley floor, which help to cool that valley in the Rogue Valley, and bring really bright, energetic fruit profiles and a lot of aromatics to the wines as well. So, you know, Southern Oregon overview focuses a lot on mountain ranges, on river systems and high elevation vineyards, some of the highest elevation vineyards in Oregon, which again help to contribute to that energy and moderation on the palate as well. Some of the biggest diurnal temperature shifts that again help to preserve acidity and bring complexity into an otherwise pretty warm region. And again, those cooling influences of the river systems, where those rivers and waterways really move the air along and help to keep the area quite balanced. Overall, how high are the highest vineyards in Oregon? Well, I would say that there's vineyards in Bend that are above 3,500 feet, or up in that area, but they're mostly hybrid varieties. Down in the Rogue Valley, you still see a lot of vineyards that are at about 2,200 feet, 16 to 2,400 feet. So there's quite a few high elevation vineyards, but mostly the vinifera vines are probably the highest elevation is in the Rogue. Yeah, Roxy Ann 1650. So yeah, pretty high elevation down there, which helps to bring Irvine is at around 2,000 feet, and they're on the edge, the foothills of the Cascades of the mountains down there. So depending on the grape variety that you're growing, elevation and aspect can be, really used to your advantage. And so Irvine and Roberts make primarily Pinot Noir and Chardonnay. And so they're really looking to build in some of that cooler climate potential by seeking higher elevations and seeking some of that cool air that's going to trickle down off of the mountains in the evenings as well. So there's lots of things to think about and play with when you're planting your ideal vineyard or thinking about where your favorite grape might grow. And Oregon has just an absolute ton of microclimates and different varied aspects that can be really, challenging for grape growers, fun for winemakers, and even more fun for the people who get to drink them. So keep in mind, if you're looking for a place to visit where you're going to be able to get a real geological understanding of the wine that you're drinking and how the vines interact with the soils, Oregon is one of those places that is going to really, float your geek boat there for wine knowledge. So please, if there's any questions, feel free to reach out in the chat, send me a message at brie@oregonwine.org. I'm always happy to answer any questions. There's such a lot to cover here, so I appreciate you all hanging in there. Happy to ask any questions, answer any questions as well. Oh, hang on, there's an observation in here as well. What was that? There's a great book on the formation of the Oregon and Washington landscape called Cataclysms on the Columbia. Oh my gosh, I love that name. Okay, by John Elliott and Marjorie Burns. Thanks, Tom. I am definitely going to check that out. And I don't know if anyone has that as a wine brand name, but they certainly should. Thanks, everyone. I appreciate you being here, and happy Oregon Wine Month.
Great job, Bree. Thank you, everybody, for attending over the last 4 sessions. Bree, you did a great job as always. And again, if you need anything from the Oregon Wine Board, please reach out to us, Bree@OregonWine.org or David@OregonWine.org. We are here for you. Thank you so much, and happy Oregon Wine Month. Bye, all.
Thanks, everyone.